hello everyone. Thanks for joining us today for today's webinar, which is focused on the logistic regression tool in Alteryx. And then we will also have some Snowflake goodness today. So as you may know, this is a revisit to one of our most popular Alteryx webinar sessions, plus some, as I mentioned, which Kyle will talk more about later. But today, Kyle will explore practical ways to leverage the power of predictive using this tool in Alteryx, and will actually be in Alteryx today. So if you didn't have a chance to download the data files in advance, I will post that link into the chat as well. But a few housekeeping items. This webinar is being recorded, and the recording, as well as any resources mentioned today, will be emailed to you in the next day or so. And then a few introductions. My name is Rachel Mason. I'm with Technion Data Solutions, helping out with this webinar series. And then I want to introduce today's speaker, Dr. J. Kyle Roberts, who is the data scientist at Technion. A little bit about Kyle. He's held a few professorial positions at SMU, Baylor College of Medicine, University of North Texas, as well as co-authored the YHAT package in R. Kyle is also an expert in multi-level modeling and co-authored the Handbook of Advanced Multi-Level Analysis. And with that, Kyle, I'll hand it over to you.
All right, thanks, Rachel. Sure do appreciate it. Really good to be with y'all again this time. We're revisiting logistic regression, but we're going to do a little bit of a different take on it because although we are going to talk about logistic regression in Alteryx and how to do model validation and actually score new models and things like that. The other thing we're going to do, which is something we haven't done before, is we'll talk about how to connect to your Snowflake data inside of Alteryx and then actually run data, score data, push it back out into Snowflake and those types of things. And so I think it's going to be good if you're wanting to learn logistic regression. It's also going to be good if you're going to see it. You want to see, all right, how do we connect to Snowflake and just how easy is it in order to do that, which actually is very, very easy. And so as we start, though, I did want to say, if you do have questions, go ahead and put those in the chat. Rachel will be monitoring that, and so she may interrupt me if you have a question. And also, too, as a precursor, I'm going to show you the data set. One of the data sets you're going to have, which is that I'm going to show just inside of Alteryx. Of course, I can't let you have access to my Snowflake instance. So I'm just going to demo that piece. And so even though it is a sandbox area that I have, again, I'm not going to give out my credentials for our own Snowflake account here, but I'll just demo that one for you. But I will talk you through the, what are the steps that are necessary to do that. So first is an introduction to kind of logistic regression and what's going on. Now, the first thing to think about is when we have logistic regression, we're trying to predict an outcome that is what we call dichotomous, meaning it's either a yes or no, or a true or false, or a 1 or 0, or a died, did not die. We're always looking at the dichotomous outcome. And so people will ask sometimes, okay, what do you do if you have a trichotomous outcome? Okay, well, you're not in logistic regression world anymore. And depending on what that looks like if it's you're trying to predict like being in the first quartile or second or third or fourth quartile, you could use something like a decision tree to do that. That's actually not the right answer because that's still what we call an ordered multinomial. You're starting to get into really complicated things. But what we're wanting to do with logistic regression is really just look at, did something happen or did it not happen? Okay. We can also do this with decision trees. You can predict just a single dichotomous outcome for that, but I like logistic regression because it gives you a little more information about your variables and how they're contributing to this, and also in general, I think it's a better way of giving results back to someone than a decision tree with just an outcome that is dichotomous. Okay, so linear regression. If we are asking ourselves a question like, in general, what is linear regression? I like this quote that we say, it's answering the question as one variable of interest goes up, what does the dependent variable or the outcome variable tend to do? Okay, so in other words, let's suppose that we're trying to predict how much someone weighs, okay? And we have two variables in our model. We have how tall they are and then how many calories they consume in a day. We would probably assume that as each of those those independent variables, meaning how tall they are and how much they consume in a day, as that goes up, then the total weight, which is our outcome variable, would also go up. Okay, logistic regression is a little bit different, but it kind of follows the same thought. In that, we're answering the question, as one variable of interest goes up, what happens to the probability of being a 1 for the dependent variable? Meaning, we're assuming that the dependent variable is coded like as a 0 and a 1. Like 1, we observed it, 0, we did not observe it. Okay. And so we're not actually predicting how much the dependent variable is going to move. We're predicting we're asking ourselves, how much does this independent variable, meaning my variable of interest that, and so let's suppose we're trying to predict how, did someone die or did they not die? And so let's suppose they're, in 2020, and let's suppose that we have in there something about, how many times did they skydive, or how many times did they hold a weapon or something like that? Then as those variables go up, the probability of dying would also tend to go up. Now, why is this important? Because we're not predicting whether or not they're an actual 1 or an actual 0. We're predicting kind of a spectrum of probabilities. And so again, regression is not an exact science. What we're trying to do is take all the information that we have, and we're trying to say, okay, what is the probability of being a 1 based on the information that we have about that person? We can't know for sure when we're scoring new data if they are a 1 or a 0, but we can use our past data to kind of give us an idea of how good our model is working. Okay, so again, we're predicting a probability, and then we're going to make a cut point. At some point, we may say, all right, everybody who's 50% or 51% probability and above, we're going to call them, they're all 1s, and everybody who's like, say, 50% below, we're going to say that's a 0. That's our cutoff. So generally after the fact, we'll make some sort of cutoff to say, here's the people that we think are going to die, and then here's the people that we don't think are going to die. Okay, so we'll do that after the fact. But when we get into scoring data, we'll start talking about that. Okay, so a word about data types. Linear regression, your outcome variable, that should say, my bad, logistic. That should say logistic regression. That's a typo. Sorry about that. Logistic regression, your outcome variable must be dichotomous. Okay. And here's the other thing too, for logistic regression in Alteryx. Now, in everything else, this doesn't matter, but for some reason, Alteryx has this. Logistic regression in Alteryx, your outcome variable must be a string with only 2 options, meaning it doesn't have to be a 0 and 1 coded that way, but it does have to be like a yes, no, or male, female, or it is above 6 feet, is not above 6 feet, something like that. It can only have 2 options. And then Alteryx is actually going to require us to pass that variable forward as a string. So I'm going to show you this later on, that we're going to try to run it without the variable being a string and with it. So now that's for the outcome variable, or the thing that we're trying to predict. Okay. For the predictor variables, if your predictor variable is a string, Alteryx is going to automatically dummy code that for you. And so what that means is, let's say you have 4 categories, then what Alteryx will do is it will dummy code them. And so let's say you had category 1, 2, 3, and 4. It'll create synthetic variables called category 2, category 3, and category 4. And then your category 1 will be what's called the reference category. That will actually be left out of the model. But it will actually automatically dummy code those. Now, why do I bring that up? Because you don't want to use a lot of string variables as predictor variables in either linear regression or logistic regression. It's just kind of a bad idea. And the reason of that is, so let's suppose that you're saying you're modeling, you go, hey, I want to know what store it comes from. This score, this probability, the predicted probability, like what's the score or store that I'm looking at, and in your data set you have 50 stores, or let's say it's even worse, it's 500 stores or something like that. Then you're going to add if it's 500 stores, you're going to add 499 variables to your model. Okay. and you're just going to have like oversaturation. It's just going to be a really bad idea. And then interpreting those results after the fact, it's going to be really, really hard to do. And so we want to be really, really careful when we include string variables in our model as predictors. Okay, we'll be really careful on that. Okay. And again, if the independent or the dependent variable, the outcome variable, is something other than 0, 1, Alteryx will assign the 0, 1 in that alphanumeric order. So like if it's A and B, then A will get the 0, B will get the no. If it's no and yes, then C and N comes before a Y, so the N will get the value of 0. Alteryx automatically does this. Yes gets a value of 1. Again, if we have two guys, Bob and Dan, Bob would be a 0. So what's the probability of being a Bob versus probability of being a Dan? Okay, that's how that would do. Now, it's kind of a ridiculous analogy there, but it does work. Okay. All right. So now, as we saw before, the data set is available up on this website, and so you can grab those from there if you haven't already. Go ahead and download those. But I want to talk for a second about Snowflake. So for those of you that haven't been exposed to Snowflake, Snowflake is really kind of a centralized storage system that lives in the cloud, okay? And there are multiple ways that you can get data to this. And so maybe you're using Azure or Workscape or something like that, or you're trying to push data from your system out to a cloud storage device. Snowflake is going to serve as that cloud storage device. Really easy to set up, really easy to use. And so no, there are other cloud storage devices that are available out there. The Snowflake tends to be the one that's just absolutely taking off, right? Just judging by I think it was just last year when they did their initial public offering, and that just went through the roof in a matter of just a few minutes, becoming more and more popular. And so I'm not going to show you necessarily the ins and outs of Snowflake, but I am going to show you how Alteryx connects to it, can grab data out of there, can score it very easily, and then push it back up into the system. Okay, so I do want to show that, but this is, again, if we wanted, we could do a whole webinar on just, how's Snowflake, how does it work? There's tons of them out there on the Snowflake website. I think we've even done some here at Technion on, kind of what is Snowflake and how to use it. But regardless, centralized storage that lives in the cloud is really kind of the best way to think about this. Okay, so what are we going to do? We're going to move to a live demo. And the first thing we want to do is we want to do logistic regression in Alteryx. And so I want to talk about data setup and pre-processing. We're going to run the logistic regression and talk about how do we interpret those results, and then we're going to score new data. And then we're going to do it all over again, but with Snowflake. Okay, so the first one is going to be just a simple setup with just a pretty simple data set that I created. It's all fake data. Okay, and then with the Snowflake one, we're actually going to use a live data set that is real data that I think would just kind of be fun to look at. It is from a company called Lending Club, and I'll explain it more when we get there, but they make their data freely available to people. So I've got about 10,000 cases of Lending Club. Okay, all right, so what I'd like to do is let's just go ahead and go over to Alteryx. And the first thing I want to do is I'm going to pull in this data set called Logistic Train. I'll tell you what we'll do is we'll add a browse tool on here, and then we'll also add a select tool just because we want to see what's going on with our variables. Okay. So I like the select because that lets me see, all right, I've got here my variables and how they're set up. Okay. I've got the variable that's called probability readmit, that this is the probability that someone gets readmitted into the hospital. And so I have a case number, I have whether or not they had an in-hospital event, I have a test of the patient's knowledge about things that can that contribute to readmittance or to relapse of the disease that they have, or whatever the reason they have for being there. I have the number of previous admissions, and then I have something called comorbidities. So comorbidities, what that is that's like the number of contributing factors that are related to maybe having really bad health. So maybe it might be something like you have high blood pressure, diabetes, obesity, history of heart condition or current heart condition, some things like that. And so what we did is we kind of counted those up. Now, again, it's all fake data. I created it myself. But I tell you what, let's run this just so we can look at the profiles inside of Alteryx, because I think, and I am running, by the way, I'm running 2021.2. And so I really like on some of the newer versions, I forget when this happened, but some of the newer versions, this profiling that will actually appear over here in just a second. So it looks like it's trying to come up. But if you go, as it's coming up, we'll look at the data that's appearing here. So I've got all these case numbers. I've got this in-hospital event. Okay, so I've got that. And then I've got whether or not they're readmitted. Now, remember, if we look back at the select tool, whether or not they're readmitted, that is I've converted that to a string. Now, the reason I did that is because remember that we said before that in Alteryx, for the outcome variable for a logistic regression, the outcome variable has to be a string. Okay, so even that 1, 0 there, we have to have that as a string. That's the way Alteryx likes to have it. And then it looks like the knowledge test here, you see it's all a 0.22, all those values. It looks like that's a percentage that they got right. Number of previous admissions, that's on a good scale there. And then also comorbidities. And so for some reason, my browse tool, there we go, that's coming up now. So I have, looks like 82 cases here. And so whether or not they had an in-hospital event, that's 52 of them versus 30 did not. And then this probability of readmit looks like it's about half and half that did get. So 44 and then versus 38. The knowledge test, so you can see there's the values for that knowledge test. It looks like the values are, looks the high is about 89 and the low is about 11%. Okay, all right, so, oops, take knowledge test out of there. And then also previous admissions, looks like you have any values anywhere from 0 to 5. We actually, if we wanted to see more, we could go into here and we get a good, yep, min is 0, max is 5. Anyway, on the newer versions of Alteryx, I really like this, that the browse tool gives you all these profiles. So I think it's really helpful when you're doing your initial data screening, okay? And then comorbidities, let's go ahead and look at those. Looks like we have anywhere between 0 and 6, or actually, I'm sorry, 1 and 6. So it's like, looks like there's nobody that came in that didn't have at least one comorbidity, okay? All right, so there's our data. All right, let's go ahead and run the logistic regression now. So I'm gonna pull in my predictive tools. And now also too, if you don't see this tab, that may be because you don't have the predictive tools loaded. And so you may need to look back at your, meet with your, whoever your Alteryx administrator is at where you're working, make sure you have those installed, okay? So I'm gonna pull in this tool here, Logistic Regression, and then we'll talk about setting it up. So I'm gonna call this, I always like to name the, name my model so that I know in future references. So I'm going to call this LR1, and I want to select as my target variable readmit. Now, if you'll notice, when I click on the select target variable, the only variable that appears is readmit, even though I have a whole bunch of those variables in my data set. And the reason that is because if we go back to our select tool, that's the only one that's an actual string. And remember, I told you before, whatever your outcome variable is, it has to be a string. Okay, with 2 cases. So let's go back into the logistic regression. Readmit is my outcome variable. And I tell you what, we're going to include all variables just because. Why not? We'll just include all of them in there, right? So we can customize this if we wanted to use sampling weights. And then we could do a logit model is almost always going to be the way you're going to want to go. We could do a probit or a complementary log. If you don't know what these are, always do logit. Okay, let's just leave it at that. We can do cross-validation. This is a way to do it inside of here. I prefer to do my cross-validation on my own, meaning that I actually plan out the number of folds and trials based on how big it is. We could do that inside here. It takes a while to run, so I'm not going to do that today. And then if there's any type of plots, the plots actually are some things that'll let us look at how good the model is performing. Okay, so after having said that, I'm going to right click on this. I'm going to add all my browses, and then we will run this, and we'll talk about what the results mean. And it'll take just a second. This is running inside of R. So it's just has to spin up an instance of R, and then we'll get our results here. All right. So I'm going to start from the top and work down. Okay. So the first part is that this top, this O, that is the object that's passing through in Alteryx from R into Alteryx. And so when we do things like score models later on, that this output node, that's what we're going to use. Okay, the output anchor, that's what we're going to use. Now, this anchor is a report anchor, and I open that in a new window just so we can look at it together. If you are familiar with R, then this is very familiar to you. And what Alteryx is giving you is the actual R output. So here is, if I wanted to run this inside of R and not in Alteryx, I would use that formula right there, and I would just replace, where is it? This data equals the.data, I would replace it with whatever my data set's called. Now remember when we did before that we said family equals binomial logit, okay, well, that would be, if we change it to probit, that would be probit or complementary log. I think log is just LL in that, but I can't remember. I think it is anyway, okay. So now this gives us an idea as to the relative importance of our variables, our outcome variables. And so really the question we're asking ourselves is, are each of these variables, are they good at predicting whether or not someone's going to be readmitted into the hospital? So what we want to do is just read across. Now, this first thing, this intercept, that we don't need to worry about that. Unless we're wanting to actually build out, what does the model look like, and then predicts someone's logit score and then transform that into a probability. But for the most part, we just want to leave that alone. Okay. All right. So case number. Oh, you know what I did? I should not have included case number. That is my bad. We need to rerun this. So my apologies. We do not need case number in this file. So let me take case number out, and then we'll rerun that. My apologies there. Yeah, knowing someone's case number probably helps a lot with interpreting whether or not they're going to be. Okay. All right, so let's run that, and then we'll pull this up. Okay, much better, much better. Okay. So let's look at this first one, in-hospital event. This is, remember, this one was a yes, no, okay? So here's how we would interpret it. This estimate, because it's positive, what this means is for every 1 point change in in-hospital event, and in this case, so in-hospital event goes from a 0 to a 1, then that person has a 2.5166 increase in what's called their logit value. Now, this is not a probability, but the way to think about this is that the higher numbers do mean that you're more probable for being a 1. Now, we have to interpret this in light of the scale of this variable. So the in-hospital event, that's just a 0 and 1. So the max that it could move is 1 point. And 2.5 logits, for those of you that do know logistic regression, that's a pretty good amount to move just for a 1 point move. Okay, so we're looking at this, that standard error, and then derives that z value. If we look at the probability of z, this is your p-value right there, and we really care about whatever our criterion is. Let's say it's 0.05. Anything in here that's below 0.05, then what that means is this is a statistically significant predictor of whether or not they're going to have, whether or not that person is going to be readmitted. So the way to think about this is, because this is positive, 2.516, and it's statistically significant, what we're telling ourselves is that whether or not a person has an in-hospital event does contribute statistically significantly, does contribute towards them likely being readmitted at a future date. Okay, that's what that's telling us. Because it's positive and because it's statistically significant, yet that is a good predictor of whether or not they're going to be readmitted. Okay, so someone not having an in-hospital event means that probability goes down. Okay, the knowledge test. So the knowledge test here, and again, remember, it's for every 1 point change in the knowledge test, and our knowledge test was actually on a 0 to 1 scale, but it was a percentage. So that's telling us that as people know more, which does not make sense at all, but as people know more about their disease, their probability of being readmitted actually goes up. Okay, the probability of being readmitted goes up. But that value is not statistically significant, so we wouldn't trust it. But supposing it was, what this really means is that people who know more about the diseases they have probably know more because they're in the hospital a lot more with their disease. Okay, that's probably what that means. But it's not statistically significant, so we wouldn't necessarily trust it, okay, to be a good predictor. The number of previous admissions, also the more admissions, that's positive. So the more admissions you have, the more likely you are to be readmitted. However, that value also is not statistically significant. So it's saying we're not necessarily a good predictor there. But then comorbidities, this one also positive. So more comorbidities, that is statistically significant. So we would say, yep, comorbidities, the more you have, the more probable you are to be admitted into the hospital or readmitted. So remember, there are comorbidities scaled from 1 to 6. So in other words, we're seeing what's called a logit change of almost 6 points as that goes from 1 to 6. So that's actually quite a bit more change. Now you can't interpret, we'd have to do some math to interpret that as a probability. You know, for every 1 point change, how more probable are you? But that may be a little bit beyond the scope of what we want to do. But suffice it to say, all that we're doing is if we're looking at this table, here's how we would interpret this. Whether or not someone has an in-hospital event, and then the number of comorbidities are definitely contributing factors to people being readmitted into our hospital. Knowledge, how much they know about their disease, and then also the number of previous admissions tend to not be, but also we have to temper that because really we're saying they tend to not be in the presence of these other variables. So they may, by themselves, they may be an okay predictor, but in the presence of these other variables, they're just, these two here are just not helpful at predicting whether or not someone's going to be readmitted, okay? So we are going to look at a couple other things, this McFadden R squared, we're going to make a note of that, but Alteryx did a really good job of giving us a better way of looking at that. And so that's this third browse down here. And so I like this a lot because we can play with this. Okay, so the accuracy, this 0.817, let me tell you how they get this. Now, again, those of you that are really familiar with logistic regression, you'll look at that and you'll go, oh, that's a Huberty index. And so, and you're right, that's exactly what this is. And how we get that is that's the number of people that we're correctly classifying versus the total number of people in our study. So here's how we think about this. We take the total of the green people in here. So there's 33 who were predicted to be positive and were actually positive. And there's 34 who were predicted to be negative and were actually negative. And we divide that by the total number of people. So if you're really interested in actually getting those numbers, so we'd say it's 67 divided by, so was that 82? Yeah, 67 divided by 82. So 33 plus 34 is 67 divided by the total number of people in there, that's 82. And that gives us this 81.7. Again, that's what's called our accuracy. And that's also our Huberty index. Okay. We also got our F1 score. This is good if we're wanting to compare multiple models to each other, but really I derive a lot from this Huberty index or this accuracy scale. Okay, so I think that's pretty important. I was trying to think if you hover over these, if they'll tell you kind of where they derive, but really this drives the bus for me. Okay, these conditional density plots, they give you some information about what's going on with each of our predictor variables. So in other words, this in-hospital event, this is how much they're contributing to the probability of being of returning. The knowledge test is kind of all over the place, as we saw that wasn't a very good variable. Comorbidities, as those go up, previous admissions, and also as it goes up, the probabilities are rising, but that is not, in the presence of those other variables, it's kind of telling you we're not seeing that much there, okay? And then the last one, the performance, this is called a Roc chart, or some of you know this is a Roc curve, okay? What you're looking at on this is you're wanting to see a curve here where this blue line is as far away from this straight orange line as can be. And so we love it when lines do really steep lines, okay? So like a steep curve like that, if you're following my cursor there. That's really, really good. That means your model is doing a great job of explaining. When you see this blue line that's really close to this orange line, so it's like something like that, something along those lines, then what it's doing is it's not doing a much better job than if you randomly assigned people to a different category. You just said random assignment. So we like to see this curve looks good to us. And so in other words, the way we're looking at this, ROC curve or the Roc curve, if you want to call it that, that's good. That means our model is functioning pretty well. The other thing is that the accuracy is 81%, almost 82%. That's good. For classification, we would call this as a pretty good model, okay? But we always want to test competing models. And so I do want to take just a moment and pause. Rachel, did we have any questions thus far?
No questions. One comment, I guess it is a question. Will the completed workflows be shared after this? Is that something that you'd be able to share?
They're not going to be very complicated, but I tell you what, if you shoot me an email, I'll send you the completed workflow. I'd be happy to. Yeah.
Perfect.
Okay.
All right. That's it.
Okay. So let's do a competing model. And here's what we want to remember. Accuracy 0.817. That's the thing we want to keep in our mind. Right? That accuracy 8.817. That's kind of like how good are we doing? It's almost like we're saying 82% good. It's not quite that, but that is. Okay. So what I'd like to do is let's run another model. But this time, let's take out the variables that we don't think really contribute to our model, because parsimony is king. All right, let's take out this knowledge test and let's take out the previous admissions. Because remember, we said before that those really aren't doing much for our data. Okay, as we looked at those, both of those were not statistically significant. And let's see how much we lose by getting rid of those two variables. Let's see, does that help us? Does that hurt us? If it does hurt us, how much does it hurt us by leaving those out? And again, I'm very much an Occam's razor type guy, that if you have multiple solutions, then the simplest solution is usually the most right solution. Okay, so having done that, let's go to this bottom browse and let's see what we have. I tell you what, I'll open it up in a new window. Okay, so our accuracy dropped to 79%. Okay, 79.3. So what we did, and here's in essence how we're looking at this, by dismissing two variables from our model, we only lost 2% in terms of classification, correct classification. That's not much. Like I'm really, really happy with that. Again, simpler models are easier to explain. Because we always have to ask the question of, okay, this is how well this variable functions in the presence of these other variables. So I like this a lot. So if I'm building a model and I get one, I go, okay, so I've got 4 variables in the model predicting, and the accuracy is about 81%. I drop 2 of those variables, I only lose 2%. That's totally worth it to me. Totally worth it to get rid of those other 2 variables. I look at this and I go, hey, I'm pretty pleased. This would probably be the model that I would go with. Okay. All right. So let's suppose you decide, I like this model. I love it a lot. Oh, by the way, I've got this other data that now I need to score it. I need to figure out what's someone's probability of being readmitted. Now, these are people that I have data on, but I don't have any information. I mean, they haven't actually been readmitted yet. Okay. Because they're still in my hospital. So what I'm going to do is pull that data in. And so I'm going to pull in another input data tool. Right, and I'm going to grab this time this logistic 2 score. And when we look at this, we'll see, okay, these people are still in our hospital. They have not been, we haven't actually readmitted them because they're there right now. Here's their case number, whether or not they had an in-hospital event, knowledge test, previous admission, comorbidities. But notice the variable that's missing is, were they readmitted? Now, the reason it's missing is because they're still in our hospital, right? So what we want to do is we want to score these people and find out who is most probable of being readmitted. Okay, so I'm going to go back to my predictive tab, and there's this button here called score. I can pull that down onto the canvas, and you'll see that score has 2 input anchors. There's a D and an M. The D stands for data. meaning that's the new data that you want to score. And the M stands for model. Okay, that's where we're going to get the input from the previous logistic regression. So let me grab this D and I'm going to pull it over here to my new logistic to score data and connect that. And then now I'm going to grab this O anchor. It's the top anchor. I'm going to grab that from my logistic regression model and pull it over to the M there. And that way the model is going to come in. Okay. I'll take just a second. All right, we do want to configure this a little bit. Alteryx is going to make for us 2 output fields, okay? And those output fields, we want to name them because we don't want Alteryx to just pick a name for us. And so we're going to name this readmit, okay? And then, admit. And if we did have an oversampling value, we could put that in there. If we did want to transform our data, we would do this because if our data were like a non-normally distributed or something like that, we could do those. Okay, for linear regression, we're not going to do that in theirs. In this logistic regression, we're just going to leave everything as is. Okay, and then I want to go ahead and add a browse on to the end of this because we're going to want to play with it after we're done. Oh, come on, there we go. Add a browse after, and then I'm going to hit run. Okay, now again, that model is going to run now. And after the model runs, then it will push it out to the scoring tool. It will grab the data from our new data set that we need to score, and then it's going to produce a pretty cool output for us. Okay, so let's give that just a second more. Okay. So you see we have 2 new variables in our model. We have readmit 0 and we have readmit 1. Now, what are these? All right, well, if you're looking at them, you can see and you go, let's see, 0.825 plus 0.175. Oh, that adds up to 1. Right, it does. So what Alteryx is doing is it's giving you the probability of this person, this first person being a 0, and the probability of them being a 1. Now remember, the model that we chose only had 2 variables in it. It had in-hospital event and the number of comorbidities. Okay, so this person did not have an in-hospital event, but they did have 5 comorbidities, but their probability of being readmitted is actually only 17%. Okay, because this is the probability of them being a 0, which is not readmitted. Okay, let's try this next one. They did not have an in-hospital event, and they had 6 comorbidities, okay? So this person, and this is nice to do this because now we can compare. What is the change in probability of being readmitted for someone who has not had an in-hospital event when they move from 5 to 6 comorbidities? Well, it goes from 17% probability of being readmitted to 38% probability of being readmitted. Okay. Now, let's look at this next person here. They did have an in-hospital event, right? They did have an in-hospital event and they have 6 comorbidities. Yeah, this person's coming back to us, right? 90% probability of being readmitted. Okay, that's their probability of being readmitted. All right, so, but let's suppose that you wanted to take this data and you just wanted to say, hey, I don't want to have to look at these probabilities. I just want you to give me a yes, no answer. All right, some of you are already thinking, this will be pretty easy to do with a preparation tool. All right, the formula. So we're going to bring that in. All right, and so we're going to make ourselves a new variable in here that we're just going to call it readmit. And I want to make sure that this comes across as a double. Actually, we don't even need to do that. We can make it a byte. Okay, so here's what we're going to say. We're going to say if readmit 1 is greater than 0.5, then 1, else 0, and we'll do an end if there. Okay, so in other words, what we're doing is we're now making ourselves a dichotomous variable, and I'm not going to call it readmit. I'm going to say, because I wanted people to know afterwards that this is predicted readmit. Okay, so if that readmit 1, if that probability is greater than 0.5, then I'm going to say, hey, this person is likely to come back. But if it's not, then I'm going to put a 0 in there. Okay. And so I'll tell you what, let me cache from here and work forward because we're going to play around with that for just a little bit.
And one quick question, Kyle.
Sure.
So if there's a difference between the probability of such as Z value and then Z value, which one is considered more significant?
If there's a difference between the probability of Z value and the well, the Z value is actually, what that is that in logistic regression, that is in the old days, like before computers, you would actually take that number that's pretty easy to compute. It's just the estimate divided by its standard error. You would take that number and then you would go to this huge chart that you had like in a book, and you would pull that book up and then you would say, all right, based on my Z value, what's the probability? And you would look at that number. That way they would give you that number. And so we really don't need that Z value in there, but it's kind of left over from days of old. And so but it's just that Z value is what we use to determine the P value. So you really don't need it. But you need it to derive the P value, but you don't need it. I mean, it doesn't really mean a lot to you. So
sure.
Yeah,
and then the following question is there a specific number that's considered significant? And would that be 0.005, for example?
Yeah, most people, this is pretty arbitrary. Most people say 0.05 or below, but there's this great article by two researchers, Rosnow and Rosenthal, and that they argue in that we kind of randomly set that number at 0.05 just because that makes us feel good. And they had a great quote where they said, surely God loves the 0.06 nearly as much as the 0.05. And they were just joking at other statisticians, just saying, why do we say 0.05 is our criteria? It doesn't make any sense. There's also a really good article by a guy named Jacob Cohen that I think the title of the article is "The Earth is Round, P is less than 0.05." Right. And again, so he is also kind of making fun of people who are just would say, all right, 0.05 means you're statistically significant, and that's really, really important. And so I say, now I can publish my results. And one of the arguments he makes is, you know what, in cancer research, we may want to relax this a little bit because, you know, we may reject something that maybe is at a 0.06 p-value, and that may save 100,000 lives next year. And so, but for the most part, people say 0.05, and it's just kind of a random number they pick. I could do a whole hour on that, so I'm gonna leave that as is because I do have some definite opinions on that. I've actually written a few articles about the arbitrary nature of those p-values because they are very much affected by your sample size. So bigger samples tend to produce smaller p-values, and so yeah. We'll leave that right there, but that's a good question. Below 0.05 usually. Okay. So
thank you.
Okay. But you can see now just by pulling in that formula tool, we now have a predicted readmit. Okay, so that's now it's on our 0 to 1, and we can pass that off to other people, and we can say, all right, here's our 0 and 1s, and there we're good to go, right? Okay, so we're ready to go. These are the people. And so what you may do is then create a system inside your, again, if you're in a hospital for this one, that then, you know, you create a run button for them that before you discharge someone from the hospital, you run this algorithm in order to predict whether or not they're likely to come back, because as many of you know, hospitals, they pay pretty serious fines if they have a lot of readmits. And so all this is doing is this would say, hey, this person's probably really high probability to readmit. Are we sure we want to let them go? And so, you know, this could run every hour or something like that. Or, you know, when somebody clicks on the button and says, hey, we're getting ready to discharge this person. Okay. So that's kind of how you would use that. I wouldn't want to give these numbers to people because they're hard to interpret, but I would want to set my criteria. And maybe let's say you want to be overly cautious, you know, there. And so instead of saying it's below or above a 0.05, maybe you want it above a 0.35, as to say, hey, these are the people we want to say, anybody that's above a 35% probability of being readmitted, we probably want to keep them, or we want to generate a flag. And so now, you know, when we run that, so now we have more people. So now, like the second person, now we're catching them. okay, whereas previously before we were not. But that's up to you. That's more philosophy than it is actual stats, okay? All right, well, we've got 15 minutes here left, and I want to make sure we get to Snowflake because this is kind of the fun stuff, right? Although that's fun too. All right, but let's access Snowflake. Now, the first thing I want to add is that you do have to set up your Odbc connection. Okay, and so if I were to, again, the easy way inside of here is just to type, Odbc and type my search engine, and then I could look up my data sources, for my 64-bit. I'm not going to pull those up because I don't want you to see all my data sources, as you well understand. But they do have to be set up first inside of here, and you have to pull in the Snowflake driver. But there's some really good articles up on the Alteryx website on how to do this, like really, really good articles on easy ways to do this, okay? So I'm going to drag in, a new input. I'm just going to use the input data tool. We could do in database, and if we have time, I'll show you how to do that also. But I'm going to grab in an input data tool, all right? And so now, instead of connecting to a file, what I'm going to do is go to data sources, and then connect down here. You'll see Snowflake. There it is. There's my Odbc connector. Okay, so Alteryx has a lot of stuff in here. Okay, now I need to stop sharing just for a second because I got to enter my username and password, and I don't want to have to change those in 3 seconds. So let me stop that, enter those. Okay, all right, let me reshare again. Okay, all right, so I'm in. I don't mind showing you this because this is our Technion sandbox. So everything in here is kind of that's the stuff we just play around with and we do demos with. I'm Kyle Roberts, so there's my KR sandbox. So I'm going to click on that to open it. And what we've done is I set up, again, inside of Alteryx with my Odbc connector, I set up which schema I wanted to grab and, in which play area I wanted. I do have access to the other ones, but I'm just going to look inside my own sandbox. And I have inside here, I have some Alteryx demos that I want to pull in. And so again, I'm going to click that plus. It's not responding. That's fine. There we go. Okay. And so now I've got all these data sets inside of here. Okay. I'm going to pull in this one that's called Lending Club Test. Okay. So all I need to do is double click on it in order to do that. And then what I see is this visual query builder over here. You put checkbox next to star. And what Alteryx actually does is it writes the SQL code that I would need in order to get that. Okay, so it's grabbing from my sandbox and the Alteryx demos, Lending Club Test, that table that's in there. And if I wanted to, I could just test this query just to make sure the connection was made and there's no parsing error. This is nice also because instead of, let's suppose you have something that's pretty complicated for getting from multiple tables, you could actually use the SQL editor inside of here to grab multiple things at once instead of using the visual query builder. But I'm going to go ahead and hit OK. Or just grab the the variables that you want. And so let's see though. I'm just going to do this. So let's suppose I grab these 3 variables. Again, I go to my SQL editor. You see all 3 of those are there. So really nice, really great touch. Impressed. Way to go, Alteryx. Make it super easy to grab this data. And then I'm going to click OK. All right, and then there's all my information out of there. The password is encoded inside of that. And so let's go ahead now to browse. And then what I'm going to do is I'm going to cache this. Oh, come on. I'm going to cache this so I don't have to ping Snowflake every time. All right, so here's my data. This is a really fun data set and good to play around with. And so what we are really caring about is there's 5,000 loans here. And in these 5,000 loans, I'm going to care about this one right here, is bad, this last column. And if we look at this, so we'll go down in these profiles. Oh, get all the way down there. Okay. We'll look at this in the profiles here. We can see of those 5,000 loans, it looks like we had 595 of those that went bad, okay? And so what we want to do is, based on all this information that we have about these loans, we want to try to predict hey, how can we know if a loan is going to be bad or not? Okay, how can we do that? So in a lot of the variables, they're pretty fun. We have information about the zip codes, the address, the state that it's come from. We have information that we can't use inside of Alteryx, like the title of like what they're wanting to do, buying a new computer. That would be really kind of too difficult to do. We'd need to use some NLP and stuff in order to do that. I love this one. I need to pay rent right now. That's why I need money. I'm in desperate need of $500. So just curious, we can look at row 4 and just see, did they pay it back? You know what, they did. That's great. Here's one that did go bad. That's row number 11. And we can look at this data and go, okay, this was for $1,000 for 36 months at a pretty high interest rate. And if we're looking at, they needed help with their mortgage, it looks like. And then they call this a major purchase loan, okay, that they're looking for. But we also have information. We haven't do much of text information in here also about where the people work. So here's someone who's working at Tim Hortons. There's my favorite one is coming up right here. This person works for the man. I don't know that I would have funded that one. But because I don't think they're taking it very seriously. But there's some pretty interesting things in here. So we're not going to work with that. We're just going to work with the actual data that we remember when we talked about logistic regression. The predictors need to be numeric, okay, and on a scale. We don't want them to be what we call factors or if we're thinking about them in terms of Alteryx. We don't want them to be strings. Okay, so I'm going to add this select tool. Okay, and the first thing I want to do is I want to come through here and I'll look and I go, okay, here are the things that I could potentially include in my model, like the loan amount or the funded amount, and then interest rate and the installment. Anything that's a string I don't want to use. Their annual income, that may be pretty nice. But here's the thing I do want to do, is bad. Remember, we have to change that to a string if we want to use that as our outcome variable. Okay, so I'm going to change that as a string, and then we're going to build our first one. So I'm going to pull in logistic regression, and I'm going to go pretty quick through this because I want to make sure that we have time to kind of talk about how would we then score data. So I want that prediction to be is bad, and we're going to do how much do they want, the funded amount. The term, this is a string, but that's okay because there's only 2 options on it, 36 months or 60 months. So I am going to include that. And then let's include annual income. Okay, so let's include those. We'll add all of our browses and we'll let that run. And then while that's running, the next thing we'll do is we'll grab some more data out of Snowflake and we'll score that data and then push it back up to Snowflake, push the results out to Snowflake, okay? So if we're looking at our output here, we can see how well we did, give us an idea on our model. Oh, come on. Good. Okay, accuracy, not great. Okay, this is not a wonderful model. Looks like we're just above half. So which that means to us is that we're not doing much better than if we're just randomly picking and assigning people. So we see these actual negatives, that's not good. And the actual positives, we're just not doing, the reds are the ones we misclassified, the greens are the ones we correctly classified. Not great. Not great. Okay, but let's suppose we decided, yeah, that's a good model. We do like it. Again, we're just playing around right now. That's a good model. We do like it. And by the way, you can find this data set out on the web. I just can't make it. I can't give it to you myself, but it is all over the web. And it's Lending Tree actually makes their data freely available to people. It's been de-identified though. Okay, so let's suppose now we want to score some data. Well, I've got to go back into Snowflake. Okay, so let's grab a Snowflake connection again, go to data sources, and then once again, let's go to Snowflake. Oh goodness, I got to stop share just so, because every time it's going to make me enter my username and password. So let me do that real quick. We'll start sharing again. All right. So now we want to go back into that same area. And in there, inside of Alteryx demos, I have another data set. That is lending club to score. So I'm going to double click on that. And that will bring that over, and I'll select that star, which is getting everybody. Go ahead and hit OK. All right, now that data set is in there. And now what I want to do is, and we can even see on this if you want. And grab that in there. Take just a second. Okay, you can see that in this data set, there is no variable that calls is bad because this is data that we actually need to score. Okay, so now we'll pull in our scoring tool. And remember, data goes to that one. And then we're going to grab the output from this one into the model. And then we new field name is bad. Let's do is underscore bad because I'm going to throw it back out to Snowflake when we're done. And now this will score that data. But then if we want to put that data back into Snowflake, then what we could do is pull in an output data tool. And in there, we'll again grab our Snowflake area. All right, so data sources, Snowflake, and we would want to use, you typically, for those of you that know about Snowflake, we want to use that bulk loader. It goes way faster, okay? One more time, can't let you see my screen. Okay, well, I tell you what though, I'm actually going to cancel this because it's going to take a while. But what we would do is just I would put my username and password, and then this is my Snowflake connection. And then what I would want to do is make sure I'm using the user stage under this local here. So I don't want to use the Amazon S3. This would be just using the local user stage. And then that would load that back up after it ran into Snowflake. Okay. And that would be, it's that simple. That's how we do it. Okay. We have exactly 2 minutes left. We've been gone for a while. Let me pause. Rachel, are there any questions that we could answer before we're done?
We did have a few questions about Alteryx right before you switch to Snowflake, if you want to take the last 2 minutes to
sure, let's do that.
And then while you're answering these, I'm going to throw up a quick poll as well. So if we didn't get to your question today and you would like Kyle to reach out after this session, please answer that poll there and we will make sure to reach out to you guys. So one question is, can you explain how Alteryx has taken a trained data set and test data set? Is score tool being applied on a test data set?
Yes. So it is. The score tool in this case is being applied on that testing data set. So we could, now you could, if you wanted, when you're starting with this original data set, this logistic train, you could actually pull in a preparation tool here. And what you would do is use a create samples tool. And so let's suppose you wanted to go, let's say, okay, from this data set, I want a regular estimate. I want to use part of this for my estimation, part of the data set for my validation, and then a historical testing thing. We could use this create samples tool in order to do this. Now, I only had, if you'll look here in the fields, like I had, was it like 80 something rows, 82 rows. That doesn't make sense for me to do that here. But if you wanted to do the estimation and the validation, you could do that simply with this tool and just say, okay, I want, 33, a third and a third and a third split out, or however you wanted it split. Okay, that's a great question.
Awesome. Do you think we have time for just one more? This one.
Let's do one more. Yeah, let's do one more.
Is there a certain way to treat outliers in Alteryx?
Not locally, and so I have some special scripts that I've written to identify outliers, but they're really kind of germane to specific things I'm doing. So I'd be happy to make them available to you, but I don't think they would make sense because of the way I want to handle outliers in this. Now, if you do have the new, having said that though, if you do have the new machine learning stuff, there is some good in the assisted modeling. There are some good ways to look at that. They are identifying some outliers inside of there, and you can kind of grab those and see those. I have kind of my own personal way that I do those, but it involves writing a lot of code. And so an easy way to do this, yes, if you have the intelligence suite and using the assisted modeling tool, yes, you can do that. Yep.
Awesome. Well, I think that's all the time we have today. So thank you again, Kyle. We hope that you guys found this session beneficial. And again, if we didn't reach your question today, please answer that poll and we will be in touch very soon. But thanks for tuning in today, and we hope to see you guys next time.
All right. Thank y'all. Bye-bye.